Hello and welcome to the Chemistry Academy. In this video we're going to go over a summary of types of reactions that you'll come across in National 5 Chemistry. So there are quite often questions in the SQA National 5 Chemistry exams that ask you to identify the type of reaction that's taking place when you're shown a given chemical reaction. So hopefully this summary will help you in knowing what to look for to be able to tell which type of reaction is which. So I've made this summary table here and you will be able to see a screenshot of it at the end of this video for you to copy down into your own revision notes. So I'm going to go through each of the types of reactions that we often see in National 5 Chemistry and give you some indications as to what to look for to identify it as that particular type of reaction. So the first reaction that I always look for in any type of reaction question at National 5 Chemistry level is a precipitation reaction. This is because more often than not it is a precipitation reaction that they've given you in the question, and it's also one of the easiest ones to spot. So when you're looking for a precipitation reaction, all you need to do is scan the state symbols, so these things in brackets, and what you're looking for if it is a precipitation reaction is that all of the substances have AQ as the state symbol except for one product that should be a solid. This is because a precipitation reaction is a reaction where two solutions react in order to form a solid precipitate. So if you scan the state symbols, everything's AQ except for one product that's an S, then that will be a precipitation reaction. So that's the most straightforward one, I would say. If we then go into neutralization reactions, so in a neutralization reaction, what you're really looking for, first of all, is that water is a product. Now you have to be, that is not the only indication though, because as you can see further down, there are other reactions where water is a product. So that's one thing we're looking for. We're looking for initially that water is a product, but then we need to check what the reactants are. So we're looking for our reactants to be an acid and a base or an alkali. If we have reactants that are an acid and a base, and sometimes it'll tell you in the question the names of the chemicals. So just remember any acids will have acid in their name. Bases tend to be metal oxides, hydroxides or carbonates. So if the question mentions anything about an acid reacting with a metal oxide, hydroxide or carbonate and water is a product, then you will have a neutralization reaction. The product that's not water or sometimes carbon dioxide, if you've used a carbonate, is the salt, and sometimes you will be asked to identify the salt in a neutralization reaction. It's usually the first product that's written in the reaction. Then we'll move on to complete and incomplete combustion. So these two are quite similar, and these are also examples of reactions that do produce water. For complete combustion, this is where you've got a plentiful supply of oxygen. That's how the SQA normally phrase it, plentiful supply of oxygen. If we have enough oxygen available for burning our substance, then we will make carbon dioxide and water. So if you look at your reaction that you're given, that you've been asked to identify, look at the products, is it carbon dioxide and water? If so, just double check that oxygen is a reactant. If all those things are there, then it's most likely a complete combustion reaction. For incomplete combustion, this is where you've got a limited supply of oxygen. So in this instance, we don't make carbon dioxide, we make carbon monoxide. We also end up producing solid carbon, soot sometimes as well in incomplete combustion. But again, you would still have oxygen as a reactant, it's just not going to use as many moles of oxygen as it does for complete combustion. And that's because there's not as many moles of oxygen available. Okay, so for incomplete combustion, you're really looking for the products being carbon monoxide and water, and potentially the soot shown as well. If we then move on to addition reactions, so addition reactions, you often think of maths, adding together. So that is essentially what it is. If you're adding two molecules together to form one molecule, then that will be an addition reaction. You also would really be looking for one of the reactants to be unsaturated, so for it to contain a double carbon to carbon bond. This also kind of matches in with maths, because if it's an addition reaction, one of your reactants will usually have what looks like an equal sign. Although we obviously don't call it an equal sign in chemistry, but you can kind of think it like that for the purposes of identifying addition reactions. Okay, so anytime that two molecules have joined together and just make one molecule, then that would be classed as addition. Within addition reactions, you have specific types of addition reactions like hydrogenation, hydration, bromination. If you're needing some more help on that, go and check out my addition reactions video in my National 5 Chemistry playlist, and that goes through the specific types of addition reaction. However, in the exam, you are allowed to just generally call it an addition reaction regardless, provided they've not asked you for the specific name of that type of addition reaction. So then we go on to dehydration. So this is one that sometimes pops up, and it's essentially where you've removed water from a molecule. So I often think if I'm dehydrated, it's because I've not got enough water in me. So that reminds me that then a dehydration reaction involves removing water from something. So usually it's from an alcohol. And when you remove the water, you end up obviously producing water, but you end up producing something that's unsaturated as well. You end up with a double bond in there. So that's just one that we don't really probably do that much on, but it does sometimes pop up. So just remember, if it looks like water has been removed from one molecule, then it will be a dehydration reaction. And then lastly, we have what combine to give you redox, reduction and oxidation. So these two, remember oil rig when it comes to oxidation and reduction reactions. But for a reduction, you're looking for the electrons to be a reactant because they're being gained. So you're looking for them to be on the reactant side. For oxidation, you're looking for the electrons to be a product because they're being lost. So they're being given away. And that brings us to the end of our types of reaction summary. So it was quite a quick whistle-stop tour, but just get used to practicing. When you're doing your past paper questions and you come across types of reaction questions, have this summary sheet handy, just so you start to get used to what you're looking for each type of reaction. But like I said, most of the time, the general what type of reaction is this, it ends up being a precipitation reaction. So yeah, I hope that helped. If you find this video useful, please give it a like. Don't forget to subscribe, and I will see you again soon.